And what I need you to do now is I need you to go to this site called Jeru.org. So it's JEROO.org, like this. And you don't need to create a login or anything. All you need to do is just hit this yellow button that says start coding. Now I need to explain to you what's going on here. Let me make this a little bit smaller. Okay, so this is an island. This is an island, and the blue represents ocean, and the green represents grass. And these creatures here that look like kangaroos, they're Jerus, and they hop around on the island. Now, what do you think happens when one of the Jerus goes for a little swim here? So, kangaroo in the water, what do you think? It dies, yeah. So try to keep the kangaroo out of the water today. Now, you can play with this island, and you can change it around. So what I'd like you to do is go to Island Edit and hit the water here like that. And then you can like add like little water traps here and stuff like that. You see that? And then if you decide you want to put the grass back, you just click on the grass and you can put the grass back like that. That's going to be important because one of the exercises I'm going to give you today is to modify a maze. And in order to modify it, you're going to have to modify the island. Now, we're going to solve a maze today, and it will be painful to build a maze because it's rather intricate. So instead, I'm going to have you load the maze from a file that's already established on your Google Classroom. So we're going to load the maze together. We're going to go to Island File, and we're going to say, you know what, let's go to Google Classroom first, sorry. And you can see that there is this Jeru rat in a maze problem. You click on that, you'll see that there is a maze file that's given to you. So you want to download this file right here. Let's see, how do you download it? You just click on it. Yeah, so you just hit the download button and it will download onto your PC. Now, once it's downloaded on your PC, you can install it right here by going over to Island File Open and clicking on that maze1 file. The JEV suffix means it's a Jeru environment file, which is an island file. And you can see here, there's this fancy maze that's right here. You see that? Okay. Now, believe it or not, this is a tool that I use in my Intro to CS class, which I'm not teaching this year. It's a fantastic tool because it's like Java Lite. It's like a subset of Java. It turns out that unlike Java, there's only one class in Jeru. Can anyone guess what the class is called? Yes, sir. That's right. The only class you can have in Jeru is Jeru. And because we want to make things nice and simple, instead of saying public, static, void, main, string, args like this, which you're used to doing, it's much simpler. You just go method main like that. Now I'm going to increase my font size a little bit here so you can see. There's my method main. You see that? Now I want to show you some things about this island. You notice that if you take your cursor and you put it on a square on the island, you'll see at the bottom of the island, you'll see it'll tell you what the cursor location is. Like right now, I'm at location 05. If I go to the top left, you can see that, I guess this is the top left right over here. That's 00. And if you go to the bottom right, you see that's 2323. And if you go to the end right over here, you can see that's 023. And if you go down here, you can see that's 230. So that gives you a sense of what the coordinates look like. So what we're going to do is we're going to create a Jeru. And can anyone guess what the syntax would be for creating a Jeru? Remember, this is Java-based. So let's see. Mr. Mariak, sir, I want to create a Jeru. What do you think? So if we do that, Jeru J equals new Jeru, and then we hit this step button over here, you can see it's just about to execute that line. And then when it executes it, you'll see that something bad will happen because you can see that right here, it says Jeru started in the water. So that Jeru is already dead. Mr. Mariak has killed him. And the reason why is that location 00, you got to rewind here. This is the rewind button. You're going to need that a lot today. If you go to location 00 where this Giroux was born, you see there's water there, and that's not good. So we want to have the Giroux be born on one of these grass fields, and the starting point for this maze, even though it's not well listed, is right here. It's at location 19-0. So we want to have the Giroux be born there. So I'm going to put Giroux 19-0 into the coordinates for the constructor, and that will tell the Giroux to be born there. So once again, I'm going to rewind and hit step, and this time you'll notice, and there's the Giroux. It doesn't look much like a kangaroo, but it does show you the direction that the Giroux is facing, which happens to be to the east, like that. Now, let me explain to you the things the Giroux can do. By the way, this Giroux is so popular that Google has integrated all the Giroux features into Google. So if you were to go to Google and say, what can a Giroux do? You'll see that it will give you a list of all the things that a Giroux can do. It can pick flowers, plant them, give them to other Giroux. You can see, you can toss your flowers. You can look at all this stuff here, all integrated right into Google. Very nice. Anyway, getting back to our Giroux here, I'm going to show you some simple commands for Giroux. So notice it won't let me modify the program. I got to keep hitting that rewind button, which I always forget. One thing you can do is make the Giroux hop. Can someone tell me, Mr. F, sorry, how do I make the Giroux hop one space, sir? J.hop, very good. Like that. So now if I run this puppy again, you can see there's the Giroux. Now it's on the highlighted line and hasn't executed it yet, but if I click it again, you can see the Giroux has hopped. You see that, right? So now what we're going to do is we're going to show you some other commands that are basic to the Giroux, because you're going to need some of these basic Giroux commands to navigate this maze today. So it's all pretty much Java based. So you can say things like if J dot is clear ahead. Let me show you what that does. And basically that will tell you if there's a nice green field in the spot that you're facing. So right now you can see if I go, if J is clear ahead, the answer is yes, it is clear ahead. If you're at this spot though, it won't be clear ahead. What will be ahead? If you're at this spot right here, why isn't it clear ahead? Because there's water ahead. See the difference? So right now, and this is useful so you can figure out how to stay out of the water. Now, if you need to turn the Giroux, let's say I want to turn this Giroux. So let's say I go 2 hops here, right? And then I want to turn. So I would just go J.turn, and then you just go left like that. So let me show you now. Here's the Giroux. It hops once, it hops twice, and now it turns. You see that? So that's how you turn a Giroux. So the other thing is we're using this Giroux and the flower to simulate a mouse going through a mousetrap and chasing the cheese. So in our Giroux here, that the flower represents the cheese and the Giroux represents the mouse. We want to make the Giroux smart enough to be able to navigate through this maze so that it stays out of the water and basically looks at every square possible here. Now, these squares here are not even reachable. I don't know why they put that there. Anyway, it's going to hunt through these squares in some systematic fashion and eventually find its way to the flower. And then when it gets to the flower, we're going to declare victory. Now, what I'm going to show you today is, now you can do the basic Java stuff, like you can go else if here. Let me get that rewind button again. You can go else if, and you can put more stuff in here like this. And that's going to be useful to you when we implement our algorithm, which I'm going to show you right now. We're going to learn 2 algorithms today for solving mazes. The first one we're going to solve on Giroux, and that one remarkably does not use any data structures or any memory. And the fact that this algorithm works so well is really kind of head-scratching, but it works really well. It's got only a certain class of mazes that it can solve, however, and we're going to try and figure out which mazes it can solve and which ones it can't solve a little bit later today. But right now, I'll tell you that this maze is indeed solvable with this algorithm I'm going to teach you. We're going to put the Giroux aside for a moment and talk about the algorithm for maze solving. And as I mentioned, this first one doesn't involve data structures, but I want to show it to you because it's just a really good thing to know. And then we'll do the data structures version next. So let's go over to our little example of the mouse and the cheese. And this algorithm I'm going to show you is called the feel the left wall algorithm. You're going to feel for the left wall. So let me show you how it works. Right now, you can see that this mouse is right here in the starting position. It's trying to find this cheese, which is over here in this position over here. And what the mouse is going to do is it's going to reach out with its left hand and feel on the left side to see if there's a path to its left. Is there? There is not. You can see that there's no path to its left. If it checks to see the left wall and there's no path there, the next thing that it checks, according to my list here, is there a path in front of the mouse? Is there? It is. So it's going to go forward one space like that. Once again, it's going to check to the left. Is the left clear? No. Is the front clear? Yes. Goes here. Left clear? No. Front clear? Yes. Is the left clear? It is. When the left is clear, like that, the mouse is going to make a left turn. And it's going to hop one space. Now we're going to check the left wall again. Which is the left wall? Is this the left wall? Is this the left wall? Is this the left wall? Or is this the left wall? Which one is the left wall here, Mr. Alejandro? The bottom one is the left wall. Is the space clear to the left? No. So it's going to move forward again. Now we get to an interesting predicament. Is the left space clear? Is the forward path clear? Is the right path clear? It is. So we're going to make a right turn now, and now we're facing this way, and we're going to hop one time. Now we've reached a dead end, and we'll know that by going through our algorithm here. Is the left path clear? No. Is the front clear? No. Is the right path clear? No. We must turn around. So now we're going to turn around, and we're facing here. Question: what's the left wall now? Pretend you're the mouse. Don't look at it from your perspective. Look at it from the mouse's perspective. Mr. Nikita, which one is the left wall? This one right here. Is it clear? Is the front clear? Okay, so now we're going to move forward. Is the left area clear? Is the left clear? It is. So we're going to turn in that direction now. And look, we've just navigated this dead end and cleared it. Now we're going to take another hop. Now, is the left clear? It is not. Is the front clear? It is. We're going to go here. Is the left clear? It is. So now we're going to turn and take a hop. Now, is the left clear? No. We're going to go forward. Now you can see the left, the front, and the right are all blocked, so we have to turn around. So we'll basically use this mouse to come this way now. And when it gets here, you'll see that the left is clear. So now it will go over here and take a step forward. And now it will go over here next. Then the left is clear again. So then it will face this way, and then this way, and this way, and then this way. Is it going to turn right to make a right turn for the cheese right now? It is not. Which way is it going to go, Mr. Ajoji? Forward. It will go forward, and it'll get stuck again, and now it will turn around again, and then it'll come here, and now will it make a left turn? It will. So now it'll go here, and it will eventually find the cheese. So you can see that this algorithm is remarkably good. It doesn't keep track of where the mouse was. It doesn't use any data structures. It doesn't use any storage. The only thing it cares about is the current position, and it can still navigate a huge number of mazes. And what I'd like you to do right now is I would like you to implement this algorithm, and this is the algorithm right here. Check to see if you can go left. If not, check to see if you can go front. If not, check to see if you can go right. If not, turn around. If you can go left, turn left and hop. If you can go front by hopping once. If you can go right, turn right and hop. And if you can't do any of these things, make 2 left turns or 2 right turns to turn around. It doesn't matter. So the only thing you need to know now is, how do you know when you found the cheese? So I'm going to show you that part right here. And we're going to use a while loop to keep going until we spot the cheese. And over here, I'm going to use this sequence of if-else statements. And you need some more of those. And I want you to fill in this part here for me to try and navigate this maze. I'm going to give you the stopping condition. We're going to say, while there is J dot is flower head. Okay, so what I'm basically saying is keep going until the spot in front of me has a flower, and then we're going to leave the loop and declare victory. Okay, so if the spot in front of me has a flower on it, then I exit the loop. What I want you to do is try and figure out what goes in here so that you can navigate this maze. I need to show you this other thing I forgot to tell you about. This is the speed control. You're going to get tired of watching it go slowly, so just peg the speed to the maximum and you'll be able to go fast. If you want to cut off parts of this maze for testing purposes, you can just go to Island Edit. For example, if you want to just cut off, let's say this part right here. See, I just cut off this whole leg right now for test purposes. If you want to put that back, you can go to Island Edit and put the grass back and restore it. So the goal today is to implement this algorithm right here, this algorithm, right? And use it to solve this maze. So once again, you check to see if you can go left. If you can go left, you want to turn left and hop once. If you can't go left, then you want to see if you can go front. If you can go front, you hop once. If these two both can't be done, but you can go right, you just turn right and hop once. If none of these are possible, you need to do 2 turns. If you're stuck on any of the Giroux commands, that's not really part of today's lesson. I'm happy to help you with the Giroux commands. Just raise your hand and I will tell you what command you're looking for. If you're interested in doing it yourself, the entire Giroux manual is right here, language summary. And this tells you everything that Giroux can do. And here are the if statements. Everything you need is here, but learning Giroux is not really part of our exercise today. We just want to use it to solve this maze. Go ahead and run it. Okay, so this is the solution. We are basically have a basic maze solving algorithm in front of us. And the next question I have for you is, can it solve every maze? It turns out that there are certain classes of mazes it cannot solve. And what I'd like you to do now is discuss with your partner, if I added a certain feature to this maze, the algorithm wouldn't work anymore. What is that feature? So let's go back to this situation where we have the mouse over here. And I want to make this maze just slightly more complicated in a way that this algorithm will fail. And to do that, what do I need to do? Mr. Adil, what do I need to do, sir? Create a loop. Now, only certain loops will fool the algorithm. Let me show you one that will. So if I do this to the algorithm right here, we're going to have a problem. Look what's going to happen. When the mouse gets here, what direction does it turn? It turns left. And then when the mouse gets here, what direction does it turn? It's going to keep going left. So it's going to get caught in this infinite loop here, and this algorithm will fail as a result. You see that? Okay, the reason why this algorithm fails when there are loops is that the mouse in this algorithm that we have is not keeping track of where it's already been.